Welcome back everybody to part 2 of the Minecraft Earth Effect tutorial series, and in the last one I showed you how to make this crater over here. Of course it's not that impressive without any of the shaders. So, in rendered mode we can see we still have our stone shader, our coal, our dirt, and also our iron, and remember, we just had some textures going into a diffuse BSDF that were going into the material output, so nothing fancy over here. But what we want to do with this crater model, which again is now one object, we took all those cubes and joined them, what we want to do is integrate this with our footage, and more specifically, we want our camera motion from the footage to match a digital camera in here. So what I mean is we have a camera, so Shift-A to add, and we're going to add in a camera. So we're going to make this camera move in the same way that our footage moves, and let's actually see our footage. And actually, like always, make that volume 0, I always forget. So we want to motion track this footage, so we have our digital camera replicating the motion of, my phone camera when I film this, and then we're going to place the crater in 3D somewhere around over here. And then I think I'm probably going to cut off the second tutorial so we can start talking about how to blend everything together. So the focus of this tutorial is getting that camera motion. And if you guys are not already familiar with camera tracking, which is kind of a subtopic inside of motion tracking, make sure that you see my motion tracking tutorial series, because I think so far I have 4 hours or 4.5 hours of very detailed instruction on how to do this. So this is just going to be an example of those things. So if you want me to go more in depth, check out those videos, but I'll try to cover the general ideas over here. Enough talking about it, let's get into it. So what we want to do is take our footage right here and track it. And the way we do this is we take our footage, convert it into an image sequence, so just a bunch of images instead of one video file, because this plays nicer with Blender, and then we're going to use a bunch of tracking tools built inside of Blender to extract our camera motion. Do you like that plan? I hope you do, because that is what we're doing. Okay, so first of all, we need to convert to an image sequence, and again, there's a way to do this with FFmpeg by typing a bunch of coding commands. We're not going to do that. We're going to do everything inside of Blender. Sorry, person who emailed me about that, but eventually I'll go over it, but for now we're going to do it in here. So I'm going to go over to the video editing workspace, so again, in your workspaces, if you don't have it, plus video editing workspace. And then you're going to get your sequencer, and we want to add in our footage, so it's going to be in here, so add, or of course Shift-A, and then we're going to add in a movie, because that's essentially what it is. It's not like shot on film or anything, but it's a video clip. So we're going to load in our original footage, and you can see it's right here. We have our video track in blue and our audio track, which is not useful for this, in green. So we can take that, X for delete, and now we just have our video track, and I'm not gonna turn all of this into an image sequence because in the beginning I'm just hitting record and it's kind of still for a moment, and at the end I'm trying to hit stop record. So we want to trim this so it maybe starts here and ends here, something like that. And the way we do that is we change our start and end point for our project. So right now it's starting at frame 1, we can have it start at frame, 30, depends on your footage. So it's gonna start over here. It's going to be a bit laggy. Right now it's going to be laggy until you play it and it's going to load into memory. That's what this orange line is down here. But our footage is going to start over here and it's going to end. 250 is a bit extreme. We're going to do a pretty short track for this tutorial, but of course you can do this any length, any number of frames for your project. I just want everything to not take forever to process and render and all this. So let's do 30 to 150. So that's 120 frames total. So let's just see what that looks like. Of course, it's going to have to load this into memory, which is a bit of a bummer. Okay, so this is the footage we're going to be tracking. And the longer the shot is, generally the more complicated the track, because maybe you have markers, like let's say we track. Again, if you know nothing about camera tracking, go watch those videos. But if we're tracking like a brick over here, it will eventually go out of the shot and eventually might be reintroduced, and you have to do a lot of join tracking. But what we're going to do is we're going to take this footage, and before we export it as an image sequence, you may already notice something wrong. So you can see this looks very washed out compared to our very rich shot on a phone footage, but it does look a bit washed out, and that's because, and we need to fix this, in the render tab, under color management, we need to make sure this is set not to filmic, but view transform has to be set to, and make sure you look over here when I do this. I'm going to change it over to standard, and you can see now we have that rich color back. It's going to be important because if we have it washed out and that's what we're going to be tracking, it's going to be harder for Blender to latch onto those features. So we want to make sure it's on standard so it looks exactly like our footage without any changes made to it. And then in the output tab, we want to make sure our frame rate's the same. So in this case, my footage is 30 frames per second, so this is fine. And here are our output or export settings is what I like to call them. You can do whatever you want. I like PNG sequence, although JPEG does take up less space. I'm going to use JPEG actually. Basically, when you're doing this, you want to use the most lossless format, so with the least amount of compression. JPEG is not good for this, but this is a tutorial. I'm not going to be too strict or anything. Honestly, you could probably get away with JPEG, but I didn't tell you that, okay? You should be using like EXR or PNG or something. So we're going to do JPEG sequence with 100% quality, and then we need to save or tell this where to output to. So in this folder icon, we're going to make a directory on our desktop. So add a folder, and we're going to call this tutorial sequence. So now we have a folder for our render. And in here, we can call our sequence underscore. So it's going to be sequence underscore 000, and then 0001, 0002, and those are the frame numbers. Of course, there are two things that aren't true about that. It doesn't start on the 0th frame. In this case, it starts on frame 30, and I guess that's the only thing that's not true about that. But we have a name, click accept, and other than that, we do want to save, and I think we're good to go. So this is a render animation scenario. We're not rendering a single frame. So either go to render and render animation, or of course, if you're a Blender Pro, Control F12 is the hotkey for that. And you see it's going pretty choppy frame by frame by frame, and what it's doing is each frame that you're seeing here, it's exporting as a single image, which is kind of nifty, don't you think? And I don't think I explained, at all or in detail why we're doing this instead of a video. Maybe I mentioned it. Blender has some syncing issues, at least it used to. I don't want to play around until 2.8 stable comes out, but you'll track your footage and it will work fine, but then when you open Blender up again, everything's going to be desynced to frame and it's no good. So that issue does not happen when you have image sequences. So right now we have this folder with a bunch of images, each one of these being a frame, starting on frame 30, ending at 150. And we just want to use that for tracking. So we're done with this, so X, delete. We don't need this anymore. We can go back to the layout, which is where we operate. And for now, we're just going to kind of ignore that this crater exists. So we've done the modeling and shading, and now we want to do motion tracking. And then in the third tutorial, we shall combine the two. So for motion tracking, again, we always go to the movie clip editor. And this is where we import, right here, import in our footage, which is a image sequence. So go to this folder, and then you can either select the first frame or click A, which there's no reason to do it. It's just habit. Click A for selecting all of them, and then open. And even though this starts on the 30th frame, what we can do is set that to start on frame 1. So the 30th frame is the first frame of this project, if you know what I mean. We're basically offsetting it. And to do that, we can either manually type in start at frame 1 and end at frame whatever, 120 I think. But instead we're going to automatically do this, or we're going to have Blender automatically do this for us by hitting set scene frames. So now we're going from 1 to 121. I guess there are 121 frames, not 120. That makes sense. Okay, so set scene frames automatically does this for us, and then prefetch loads this into memory just like we needed in the video sequencer. So now when we play this, we have our footage. Again, I'm not going to go over this in crazy detail. I did it for 4 hours, and it's my best tutorial series yet. I mean, this one's good. It's just not it. It's not as good. Let's get real here, guys. Okay, so for our camera track, we need to do a bunch of point tracks, and then by tracking a bunch of individual features, Blender can look at the differences between them, and then extrapolate how our camera must have been moving in the first place. And generally, there are a couple rules, but in this case, I would say the only rule that applies is we don't want to track a reflection, being these windows, because that's not representative of the camera moving. So if we track this window over here, and I don't mean this big window, I mean the window and the reflection right here, it will be moving different than how this wall is actually moving, which isn't good because the camera it's not a good tracker, is the point. So what we can do is use For this, let's use Affine, and if that's not cutting it, we'll go to Perspective. Again, Affine is tracking both deformation and shearing, and also translation, scale, and rotation. Again, watch the video series if you haven't. And then Perspective does true perspective changes, but Affine does a pretty good job at calculating this. We're also going to enable Normalize, so when it's tracking from frame to frame, it's going to try to ignore changes in lighting intensities. So if there's a cloud that goes by and there's a shadow that gets cast, it's going to try to ignore that. And then in Tracking Settings Extra, we're going to bring up our correlation to 0.9, which means it needs to be 90% confident each time it moves a frame and moves our tracker. It needs to be 90% confident, or otherwise it's going to stop tracking, which means we have a very high tolerance. Pretty much what that means. Now, I think the first most obvious thing to make a tracker is this number 4. It's basically begging to be a tracker. So control click, let me do that again, control click, and then we can scale it up the same way we would with S. Alt S for the search box, we're going to clip display and enable search. And we don't need this to be too big because our motion isn't that much, so we don't expect our pattern area to escape this search box. A lot of theory that goes into this, but I think I'm done saying that you should go back to that series. You guys know. If you don't, you're digging your own graves, whatever. Okay, so we have this tracker set up, and I think we are good to go. So Control T to track forwards. And then we should probably lock onto that tracker. So let's play that back. See that it's sticking on here. Of course, we want to go to the Track tab right here. And we only care about the center point. We don't care about how these 4 corners are moving. The X and Y data of the tracker, which we can see right here. Red being X, Y, green being Y. Hopefully I said that right. So all that data is basically representing where this center point is. So that's all we need to look at. Now, is this staying in the same spot in the 4? Looks like it. Very well, actually. So that's good. So Control L to lock that tracker. Don't need to touch it again. Don't want to accidentally manipulate it. And now let's go for another obvious tracking feature, being this white area. Anything with high contrast to anything else that doesn't violate the reflection rule and the moving object rule is fine with me. Fine with you too. So Control T. Easy tracker, lock that in. And hopefully, since we didn't do the full video, we only have part of the image sequence here, we should have an easy time. We could track this right here. However, we do want some distribution both in 2D and 3D, and this spot right here is very close to this one in 2D, so inside this rectangle of our footage. These 2 spots are very close, so we're not going to get that much new data. And then in terms of 3D being this 3D parking lot alleyway, these 2 spots are pretty much identical. So instead, let's go for something that has probably the same 2D distribution, which, you know, it's not that good, but a good amount of 3D distribution. This is more in the background. We can select this right here. Scale, rotate, so we're not getting any of this curb. Bring up our search box just in case the pattern area moves so much that it escapes, and then Control T. Easy peasy, lemon squeezy. And we don't want all our trackers to be on the ground, but we can do 1 or 2 more. Even a spot like this should be pretty easy to latch onto, even if it's not as obtuse. There's a word for this. It's not as ridiculous as this white spot. So we'll do this, scale it up, Control T, and it made it almost all the way. And again, it stopped tracking because, well, there's a couple of reasons, but the most likely reason is it's trying to match the pattern on the first frame. It's trying to look for this design, this pattern on every single frame. And here is where it starts looking so different because of the perspective changes that it can no longer grab on. So we can just add in a reference frame by, just scaling down a little. So now it's using this pattern to match in the future. So this is a new reference point. And we can also bring up our search box just in case it wasn't big enough. Control T. Perfect, so that's done. And now let's try to go for some things with different elevation. So you could do these poles over here. Obviously, you can do the brick wall. And brick walls are kind of a blessing and a curse. Like pretty much every intersection of these lines is a tracking point, but the curse is they look very similar. So if I track this dot right here, it would look very similar, maybe not to this one down here, but maybe if you go up the wall, it looks very similar because it's just this tessellating pattern. So you want to pick part of the wall that looks unique. So for example, if we were to pick this, it has this dark spot, which makes it unique. So I'm just going to go for this area down here, which has these dark bricks due to, the things that happen on the sides of buildings, probably. Or it could just be dirt. I don't know. So we're going to track this. And for this one, since it really is a planar surface, not that this wasn't, but just to illustrate a point, we're going to change over to perspective mode because there's just going to be perspective deformation. So again, we don't change it over here because this is the settings we get when we add in a tracker, but instead with a tracker already selected, we go to tracking settings and change it to perspective. So this has perspective, but this has affine because we only changed it on the individual level. Okay, so this should be good. Control T. Ooh, okay, we picked something that goes off frame. Let's see if it comes back. So it's like a couple bricks behind this pole. So let's see. It does come back. So we could mess with that, or we could just delete it and pick a tracker that lives throughout the whole shot. Sometimes that's the easier option. So let's go for this one that has this dot here, which makes it unique. See if that has any issues. Let's lock onto that. So it stopped tracking because it hit the margin. Did it really hit it that quickly? I'm surprised. Or is that like right below the one we picked last time? Okay, if the next one doesn't work, we're going to do some join tracking magic, but let's just try one more, like this brick over here. Control T. And this is the real deal when it comes to motion tracking. You don't always get it on your first shot. Sometimes you gotta really try a bunch of trackers and see which one is best. But this one seems to be taking the cake. I might be a bit tired, so I'm saying all this nonsense, but this is a good tracker nonetheless, whether I am tired or not tired. This is a good one, so lock that in. And then let's get one or two more on a different elevation, so being this wall. Pick something over here. None of this looks that unique. We can try it. Let's try this over here. If we pick a large enough pattern, it's going to take a lot more computation time, but there's also not going to be this repetition issue because it's very unlikely that there's a chunk of bricks that looks exactly like this one. So we can bring down the search area to save us a bit of computation time. It's not going to look for this pattern in such a big search area. So let's try Control T. And this isn't taking that long at all. I don't know what I was talking about. I mean, when you zoom out, it really puts it in perspective how not big that was. So right now we have 6 trackers that last throughout the whole shot. And ideally, all our trackers do that, but we'll see. So let's try adding I'll keep it in actually, we need to change it to perspective if we're adding one in. So perspective tracker, let's try this corner of this grayed out or kind of worn, weathered parking line. Rotate it. And again, we can look in this tracking area just to see what it is that we're actually capturing. Maybe move this over. It's always good to have your center point on something you could recognize to see if it's drifting off center. So maybe this white dot right here that you can see I centered it at. Let's move it just a bit more, holding down Shift for fine control. So let's try that. Control T. I'm thinking this is going to be good. Okay, so I guess I don't think this was a reference issue where it like looks so different from the reference, especially since we're accounting for perspective deformation. I think you can see that this is getting almost the size of the search box. So we need to either make the pattern area smaller or the search box bigger, which is what I'm going to do. Control T. And soon I expect this to maybe go off frame. Oh, okay, so it kind of did. So let's scale everything down and bring back up our search area. Control T. Again, we can repeat this 1 or 2 times until it becomes futile. Okay, so it's starting to become impossible. We can still do 1 or 2 more rounds. Okay, so let's see what happens after this point. Okay, so, whoops. Oh, so it almost made it to the end, but not quite. That is a shame. So we could either lock it in or go for a different tracker. Since I didn't last time hold on to trackers that didn't make it all the way through, I'll hold on to this one because it's perfectly fine. Control L. We just need 8 active trackers throughout the whole shot, and it's easier to do that if we have 8 trackers that exist throughout the whole shot, so we don't need to switch out which 8 those are. But let's just make sure that's centered. I'm going to look right here in this. It's actually not updating. Make sure you hit play when you're in this window. Okay. And again, that zooming in is just because we added new reference points, but you only care about the center area. So as long as that's centered, it doesn't matter. But what I was actually seeing when we did that little experiment is that this area right here stays in frame the whole time. And hopefully it has enough, unique contrast that it can latch onto it. So Control T. I'm feeling pretty good about this one. Just needs to make it to 121. Made it to 119 or 118. So let's just scale it down and see if that works. Perfect. Lock that in. And I think we should have 7 now, or 8 during half the shot, and then towards the end, we should only have 7. So starting on the last frame, shift right arrow. So now we're on frame 121. We just want to add one more tracker and then track backwards since we're on the last frame. And let's pick something that is distinct in 2D and 3D. We don't have much stuff on this side of the screen in 2D. And then in 3D, we could use something that's, further out in terms of depth. And I'm thinking that an obvious candidate, we could either do this corner over here, which I think is an obvious choice, or we can change to just a location rotation scale, since I don't want any of that perspective or affine deformation, and try to track this white dot over here might be a good option. We'll see if Blender can hold on to that. And then it's, what is it? I always forget the command for this one, for track backwards. It is Shift Control T. So Shift Control T. Okay, so it hung on for a while. We need a new reference frame, so scale that down, Shift Control T, and just repeat this process. But I think this is going to be a good one. Oh, barely. It just made it, I don't even know what I'm trying to say. It barely made it. I think that's the easiest way to say that sentence. Okay, Control L. And let's just make sure that tracker's good, so do some quality control. I just want to make sure it doesn't hop to a different white dot that it confuses with it. But I think this is good, and I think that should mean we have 8 trackers throughout the whole shot. Are those good trackers? Well, I think they're pretty good, but are they good for our camera solve? That is yet to be determined. So with this, we can turn off lock so it doesn't lock onto anything, and we can just view this. So what we're going to do is, now that we're done tracking, maybe we're going to need to add another, we're going to go over to the Solve tab, and starting off with tripod, we do not need tripod since this is a moving shot. It's not a nodal pan where it's on a tripod but just tilting around. So don't enable tripod unless you have a tripod shot. We're going to enable keyframe. Again, the quick explanation for this is there's a keyframe A and a keyframe B, and basically you're defining 2 keyframes, or more so a range from A to B. That is what Blender is going to focus on for getting this camera solve. It's going to construct a camera solve, and then from there, once it gets it, it's going to extrapolate it to the rest of the footage that isn't inside A and B. So you can pick keyframe A and keyframe B, and good pairs give good solves, but oftentimes it's kind of hard to pick these, so we want Blender to automatically choose them. And if you want to know how to choose a good keyframe A and keyframe B, go back and watch the last series. But again, what you can do is just pick 2 frames that have a good amount of difference in perspective and parallax. That's the general rule. But with keyframe enabled, we'll keep refine off. We can solve, see if we get something good. Okay, 1.34 is a great start. And I'm just going to open this up so we can see what we're doing. Movie clip editor, open up the same sequences right here, which is going to make a duplicate window, but we're going to set this one to graph. And this blue line is representing the quality of our camera solve. We want this to be perfectly flat, which would indicate an error of 0, which is obviously what we want. Again, I explained this, but the solve error is basically an average and a representation of the individual error of each tracker, and then you take those and you average them. So each tracker is going to have an error, its 2D location to the 3D location that Blender solves for. You average them, you get this number. 0 means that everything's perfect. And there are some tricks to lower this number. So starting off with the main trick is with refine. We're going to refine for focal length, how zoomed in the lens is, optical center, where the curvature of the lens. Okay, I always struggle with this one. Optical center is basically saying if you were to shine light through this kind of curved lens of your camera lens, where's that light going to go to? It's going to make a cone. And where's that going to center at? And right now, Blender assumes it's in the middle of your footage, but usually lenses aren't made perfect, so it's a bit off. And then K1 and K2 is just your lens distortion. So your image distorts on the edges, we want to account for that. So choose that. And then, by the way, if you know your camera settings, make sure you input them in here, your sensor width, pixel aspect. I don't, so I'm not going to mess with it. So now that we have refine, we can actually turn off keyframe because we're happy with the ones it chose, which I think are the default ones. And now we're down to 0.4, a little under 0.42, which is much better than 1.34. Okay, and we could do maybe a bit more correction. There's no reason not to. So the last trick that would work for this is we're going to disable the footage and look at the info of all these trackers. So I just have all of them selected, and each of these is going to tell us the average error. So a tracker with a high error, 0.885, which is much higher than 0.42, so this is making our average come out much higher. This is a bad tracker, worst offending tracker, and we want to take the ones that are bad, like this one, and take their weight, which is how much they're contributing to this weighted average. Weighted average. We want to take its contribution and bring it down, so it's not making our average too high. So already, if we no longer need to refine, if we solve this, now we're down to 0.34, just by making that tracker less effective. Let's see if we have any other bad actors. It seems like this really is the only bad one. Lower this one a bit more, and this one wasn't too hot either. Solve again. Okay, now we're down to 0.3. I would like to get under 0.3, just for bragging rights. Okay, we're under 0.3. I think I can be happy with that. No need to go crazy over this. You can always, there's a add-on that some people say is built into Blender now. It's called Refine Tracking Solution or something. So here we're in add-ons. Let's see if we can find it. Yeah, so you can enable Refine Tracking Solution, which if it still works nowadays, yeah. So it adds this panel right here that you can mess with. I'm not going to do this in this tutorial. Not in a Minecraft tutorial. Just not here. We'll do it somewhere else. Okay, so now we have our solve. So I'm going to go back to the 3D viewport where we have our crater. And now we want to bring in our camera. So set up tracking scene. What did that do? Well, you see our camera now has these dots corresponding to it. And if we play, you can see that this camera is actually moving. And you bet that this camera is roughly, with some error, 0.2976 average error. That's pixel error. So with that amount of error, it's pretty much just copying the path and the pivoting rotation of our camera. But if we go to our camera view, I guess we don't, I'm just going to make this a bit smaller if I can. There we go. Okay. So in our camera view, you can see that these dots are almost, not perfectly, but almost overlapping with our 4 tracker, our other trackers, whatever. But we have the issue that we want the floor. Again, the floor is where all these trackers are. So this kind of defines a floor plane. If that's not clear, it will become more clear in a second. We want this floor plane to coincide with this crater, since the crater should be right underneath the floor. Okay, so how do we do this? We can do it manually or automatically. Obviously, we're going to go for automatically with some manual adjustment. So the easiest way to do this is just to pick 3 trackers that are on the floor, and the floor is whatever you want it to be. In this case, we want it to be this pavement, but the floor can also be this wall. If you just, I mean, it's an issue of orientation. You could choose whatever basis, if you know linear algebra. You can use whatever, it's not really a basis, but it's a frame of reference. So we're going to choose this asphalt to be the floor. So we're going to choose 1, shift-click 2, shift-click 3 trackers to be on our floor, and you can see it's picking these 3 trackers. These are the corresponding empties. They're not really empties. We select these 3 and then hit floor. And you can see that moved our camera to a place such that those are on the floor. Okay, now when we go into our camera view, it's a bit better, but our crater is huge. So now we have this thing looking at the floor, but we don't know how big that floor is in some sense. And we can either scale up our camera, which is kind of hard because you have to move it back to place. Or what you can do is select 2 trackers, let's say these 2, and say what is the distance in between these 2. And again, we're talking about the distance between these 2 and 3D. So we're just saying these 2 correspond to these 2 empties, and we want to set a distance. So for example, if we want them to be 1 unit, you hit set scale, and now they're 1 unit apart. And that's obviously not cutting it. We want a much larger distance. And I believe we want a big number for this, so 10, and then set scale. Okay, so that's already looking a bit better. You know, our camera's bigger. If we go into this, it's kind of looking like the creator's doing a better job here. And by the way, if you're noticing that this looks a bit weird, that's because when you hit setup tracking scene, it brings in a lot more stuff than just the camera that moves. It brings in this ground plane, which is yeah, this ground plane, which it adds a new collection for and actually a new render layer for, which is just a bunch of nonsense. We don't need this. So in our background, we can just close this or delete it and get rid of this ground. So with this plane, delete it and actually get rid of this collection too. In some cases, it's useful, but for what we're doing, not at all. Okay, so now everything's in the foreground and our crater doesn't look like it has a sheet of plane over it. But if we look at this, it's looking a bit better. But now we want the crater to kind of be rotated so that it's going along the alley. And we can obviously either rotate this as an object. And what I'm doing here is I'm rotating along the z-axis. Or what's even better is keeping this as is because it's already nicely positioned and rotating our camera around. So it's either moving the object around the camera or the camera around the object. Effectively, they do the same thing, but one is a bit tighter. So what we can do, let's go back into the camera view. First of all, let's set an origin. So we know where the plane is, we know what the scale is, but where's the center of the plane? Well, we can say it's right here on this empty. So select this and then set origin. So now our crater is centered at that point. You know, we could center it here. We could center it wherever, really, as long as it's on the floor. And now we need to do our rotation. There's no real good way to do this, so I think what I'm going to go for is I'm going to set this right here as the origin, and I'll explain it in a second. So this is our origin, and then relative to this origin, I'm going to pick this tracker. So this origin, relative to it, I'm going to pick this one, and if you think about these two as a collection, not a Blender collection, but just as a set of two trackers, they form a line in 3D in between them, and we can say, Blender, make that line the, the x-axis or the y-axis. So let's say, I think y-axis is a bit more natural. So you see, we have our origin, and then it kind of took our y-axis and made sure that that line went through this point. And again, it's not perfect, but it's a good start for our orientation. So I don't think we need this anymore, so we can close it. And let's play what we have so far, which is not perfect, but it's a start. And I think now we can start moving. Again, we can keep moving our camera until we're happy with it. But I think I'm going to start moving the crater itself. So G for grab, and then along the depth, which in this case we made the y-axis. So it goes deeper into the alley. So something like that. Maybe that's a bit too much. And then one more thing I want to fix is, again, we could only define our y-axis based off two trackers, which isn't ideal. It's just a good approximation. And you can see this y-axis goes along the alley. And then down here, it kind of clips, so it's not parallel to this curb. So we want to do some manual adjustment. So I'm going to pick this camera. So I've picked the camera, as you can see. So you can do that by just clicking this. How do I deselect this? Alt-A? Yeah. So you want to click this frame right here to select the camera. And then we're going to rotate. So right now we're rotating the camera along the Z-axis. And we want our Y-axis to be parallel to the curb. So you can see we have this curb line over here. I wonder if I can use annotations for this. Yeah, we have this curb line over here. And then we want this Y-axis to be parallel to it, which is what we just did. And now we can move our crater guilt-free. And it will move kind of with this alley with the correct depth and all that. So let's put that around here and then check out our rendered view and see what that looks like. Again, it's going to take a bit because we're using cycles. Maybe we can change over to Eevee just for this. I haven't really set up the lighting well. So temporarily, we can take this area light and bring up the power to something like, I don't know, 1,000. So we can see. Okay, so this is what it's looking like closer to real time. So you can see that this crater is kind of integrating with our scene, at least in terms of motion, but it's not blending in at all. The lighting's wrong. You can see the bottom of the crater, again, in our sample, which is the finished effect. It kind of blends in with this alley. So this alley has a texture here up top, and then it goes directly to stone, and you can't see under it like we can here, so we need to take care of that. Again, we need to put this texture up here. So that's kind of this compositing and integration stuff. That's going to be tutorial 3. But the motion's looking very good. And that was kind of the purpose of this tutorial. So let's go back over to cycles. And again, the lighting settings aren't really one-to-one between cycles and Eevee, at least not yet. So we need to take our power of our area light and bring that back down to 10, I believe. hopefully, maybe I'm just not aware of something, but if I know everything about this, which probably not, but if it is the case, I hope that they do sync those up into future. So the last thing I want to do, since we're actually done with tracking, you think, oh, we're done with this tutorial, there's one more thing I want to do, and that is, and it's probably best explained through this viewport. You see in this camera, we can go into the camera properties, we have our background, so we can disable, enable, so this is our background image. And let's make that fully opaque. So this is the alpha, the transparency of the background. So what I wanted to point out is that there's this option right here called render undistorted. And if we look at, I'm going to look at the corner over here to better explain. You can see how it's kind of undistorting. So again, this is our original footage, right? This is essentially what we filmed. But when we render undistorted, it's not that it's bending it, it's that it's unbending it. So when we filmed it, we have a lens in front of our camera, even though it's a phone camera, and that's slightly curved in a way that makes our image a bit curved, it has some lens distortion. And render undistorted, just as the name says, renders the undistorted footage. It gets rid of lens distortion. So if we look at this, one of these lines across this is no line. This is horrible. That was really bad. But if you imagine a line going along here, when we have render undistorted enabled, it's going to look straight as opposed to the normal footage where it's going to have a bit of bend. And the point is, we want to take this and also render an image sequence again, but this time the undistorted version. And the reason I want to do this, the reason I want to get rid of the lens distortion, is when we put the texture on top of the crater in the areas that we don't want to see, we want to make sure we're using this undistorted version. It makes compositing easier, so that's why we need it. So in the compositing tab, we have this whole mess that was made when we hit setup tracking scene. And the good thing is, a lot of this doesn't need to be explained because we're going to delete most of this. So we can get rid of these, X, get rid of this. And I think, yeah, we can get rid of this too. So this is all we have left over. And what we have right now, this is our current setup. We have this movie clip, which you can think of as our image sequence. So this is what we inputted. This is what we ended up tracking and doing a camera solve in. So it takes this footage as a node and it undistorts it. It goes into our undistortion node and it gets rid of the lens distortion. We can add more distortion, but we wouldn't want that. So we're undistorting it. And then this one right here just makes sure that it's fitting our frame. Doesn't really matter. And we want this to be in our viewer. So it's what we see. And we want it to be in our compositor. So this is what ends up getting rendered. So just to see the difference, really pay attention to the corner right here or to the edges of the frame. This is going to be the normal footage. And then this is the undistorted footage. You can see that bit of bend, which is really undistorting our footage. So when we render this, it's going to go through this node network. It's going to take our image sequence, undistort it, and send it to our compositor. And this is what we want to render. So again, we have our color management set to standard. We have our, I guess frame rate doesn't matter if we're rendering an image sequence, so 30 frames per second. And then we'll do JPEG again. If you're doing this for yourself, do PNG, do EXR, do something better. I don't think Blender has EXR. You can do, oh, it does, EXR. You could also do TIFF is pretty good. I mean, it's very good, but my phone camera's so bad, compression's not going to really ruin anything, but. Okay, so again, when we hit render, it's going to undistort. It's going to go through this whole node network. And we want to create a new directory for this. So in our desktop, we're going to add a new folder. We can call this tutorial undistorted. And then inside of here, instead of sequence underscore, we can call it undistorted underscore. There are patterns in this tutorial. Everything should be making more and more sense, or you're getting more and more lost, in which case, hopefully tutorial 3 can get you back on board. Okay, so I think everything's set up. So control, again, make sure that you don't have this going directly into your composite. Make sure that it's going through all of this, and only then does it go into your composite. So once that's ready, control F12. Okay, and right now it should be rendering our undistorted, and the way we can tell is if we zoom in here, every time a frame pops up, there's a bit missing from the margins, and that's because it's kind of bending away those areas, which means it's actually getting rid of the lens distortion. So that means it is working. And now instead of going from 30 to 150, it's going from 1 to 121, I'm pretty sure. So we're just going to wait for that to finish. Or maybe I'm going to take a sip of water and then kind of segue into the next one. So I think we've done everything we need to do for this tutorial. We've done the motion tracking, or the camera tracking really, which is part of motion tracking. You get a camera solve under the umbrella of motion tracking. And now our crater kind of looks like it's part of our scene, not integrated, just moving with it. And now what we want to do, now that we have our undistorted sequence being rendered, is we want to take this and use it to, in some way, and we'll talk about how to do this, it's going to use projections and compositing. So projections and compositing to blend everything together. But I think that's all we have for this tutorial. So hopefully you enjoyed it. Again, since I've gone for a while now, I just want to talk about my Patreon. If you want to fund more tutorials like these, your money directly going into these tutorials, make sure to check out my Patreon. There are benefits like behind the scenes content, and I'm changing one of the benefits. It used to be you get the scripts for these videos, but I no longer write scripts because it takes me a week just to make one tutorial, which they're better tutorials, but it's not worth it to make one tutorial a week. It's too slow. So I'm thinking of adding a benefit where your name is kind of put in the credits of every video so that you're actually in the video. I think you guys might like that. So again, more importantly, the benefits are there, but really what you're doing is donating and funding directly into these tutorials. So if that's something you're interested in, please do that. I will be there. And yep, I'll see you guys in part 3, which I'll be recording fairly soon. Not tonight because my voice is gone. Probably sounds the same, but I'm like taking all my energy to make sure my voice doesn't crack every single word right now. So I think I'm going to go. Thank you guys for watching. I really appreciate it. Hopefully you learned something about Blender and about yourselves. Bye-bye.